Okay, in this video I'm going to show you how to read working drawings. We're going to do that with the help of this little wooden boat and its accompanying drawing underneath it. So a working drawing is what we call a technical drawing, an engineering set of plans, and they are laid out and they are drawn with rules in mind, with a set of British standards. And the standards are such so that somebody who makes a drawing here can pass that to somebody else working in another side of the world, for example, and the recipient of the drawing would be able to know exactly what it is that they're talking about. So there are conventions in here, there are rules and guidelines which help us understand what's going on. And I'm going to take you through some of them just now, and from time to time we'll visit the little boat that it's made from. Okay, first thing we're going to point out is the title box. This is the first clue in how to decode and read a working drawing. There are things quite often contained within this title block that tell you how to decode this. So for example, we've got the name of the school and the name of the object, the part in question, and where it comes from. Quite often what we'll also find in the title block is the units that we're using. In this case it's millimetres, it's always millimetres in woodwork, so it's millimetres that we're using down here. And we've got a little symbol down here. This is called the third angle projection symbol. And it's a little icon to denote how these things have been laid out and the rules that have been followed in the construction of the drawing. The other thing to say about a working drawing, this one in particular, is this is 4 views of exactly the same thing. So it's 4 views of this boat. First of all, up here we've got a top-down view. We've got what we call a plan. We've got a front view or a side view, which we call an elevation. And I'm not sure if this will fit under the camera, but we've also got a view over here of the end elevation. And these views all line up. Lines can be drawn down from one view to the next and across to the next, and they're all done to the same scale as well. So you're able, like working your way over a puzzle, you're able to tell which things line up with which features and what stick out bits relate to in different drawings and stuff. So by drawing these 3 things in such this fashion, we're able to get a sense of what the 3D object looks like underneath. As it happens, we've also been provided with a little pictorial view here, a little 3D view showing us the boat, at a different scale mind you, but showing us the boat as it would look in 3D. Right, sizes. The thing is covered in numbers and arrows, and these are all sizes, what we call dimensions. They're written in millimetres, and there are some funny symbols going around the place as well. Let's write some of these down. So the first symbol that you may notice is that symbol right there, and that is the diameter, that's the size across a circle. You see, sometimes with these working drawings it's not easy to infer what is circular and what is square. If I was looking at just this drawing right here, there's no sense there that that's a circle. We have to look at other views. So in order to resolve that ambiguity, we have a special symbol for when we're talking about the size across a circle. And as you remember, the diameter is the size all the way across the circle. So it says here that this funnel is 18 millimetres all the way across. The other thing you'll find is sometimes you'll see sizes which are marked with an R, and that means radius. Radius is the distance from the centre of a circle to its outside edge. We use radius whenever we're talking about half circles or arcs or anything that isn't a full circle. So over here, for example, we've got a little quarter arc right here. So we use radius, that's radius 10, that means it's 10 millimetres from the outside of the arc to its centre point. You'll also see sometimes in drawings, although not often, you'll sometimes see the sizes prefixed by a drawing of a little square. And that's just to tell you that a size in millimetres refers to a square, so it would be the same on all 4 sides. We've not got that in this drawing, but from time to time that appears as well. Some other things are visible in this drawing as well. We've got solid lines, those are the outlines, those are the visible edges, those are the things about the boat that we can see. So you can see the solid outlines on the plan view here represent all these edges that can be touched and can be seen from the top down. We've also got, however, dashed lines, and the broken lines denote hidden detail. So for example, these little holes that disappear into the boat, from a side view we can't actually see them, but we know that they're there. They're hidden, so hidden lines we show as broken. So if you like, that is the, let's just line that up so you can see. So this pencil can meet one of those holes and disappear away inside it. And it's that little sort of cavity that's represented by these broken lines. So we can see how deep the little cavity goes. And because we project or we draw the same thing from multiple different angles, we can see that those holes line up with those circles on top and line up with these lines right here. We've also got centre lines. Now centre lines appear in here. Let's get a piece of paper. A centre line is long dash, then a gap, short dash, then a gap, long dash, and it goes like this. And we use a centre line to denote things that are rounded. So for example, if I was drawing a pack of Pringles, from the front, a tube of Pringles looks like that. From the front, we don't know if that's a rectangle or a box, so in order to tell the reader that it's curved or cylindrical, we put a centre line down it like this. Also, if we have to draw circles at any point, they get a special type of thing called a centre mark, which has, it's basically a little crisscross, it's basically two crisscrossing centre lines going like this. And again, that tells us where the centre of things are. Although looking at this boat drawing, I can see that in actual fact there should be a centre mark up there and up there. Those are missing, and there should be centre lines going down these bits as well to tell us that those are cylindrical, like that. And that's how you read working drawings. Let's talk about sizes though. Let's get into the nitty gritty a little bit, okay? So how do you read these sizes that are around the place? Well, the number above a line here tells us the distance between these two lines. So for example, it tells us here, if we follow the arrow, okay, and follow the extension lines downwards, then the distance between these two lines, this distance in here, in other words, the size of this trench in here, is 25 millimetres. It tells us that the overall length of the boat, okay, there's the overall length of the boat. Let's follow the extension lines up, and we can see that this dimension line is the one that we're looking at, and we can see that the overall length of the boat is 200 millimetres, and so on. Let me rub those marks out, because I'm going to leave this on screen for a minute, and I'm going to ask you some questions about this. So if I showed you this drawing and asked you things like, okay, what size are the little holes that you can put your pencils in? This is a pencil holder. These little holes you can put your pencil in. What size are those holes? What is the overall height of the boat from the bottom to the top surface here? And how wide is the kind of helicopter deck at the back? So those were 3 questions. First one I asked you was the size of the holes. How big are these holes? We can see that they are a diameter 8 millimetres all the way across. But that's not enough. We then asked how deep do they go, and we can see that they go all the way down to the bottom here, which completely lines up with this size right here, 22.5 millimetres. The overall height from bottom to top is right there, 45 millimetres as well. And I asked you the depth of the little helicopter deck at the back. So how long is the helicopter deck from here to here? How long is that size? Well, it's not written on this drawing. Let's put our fingers out and follow them up, and we realise that the size lives up here. Now there's a special consideration when it comes to drawings of wood and wooden things. In front of you here I've got 2 wooden blocks, and each has been presented with 3 different dimensions, 3 different sizes on it. We're told that from here to here it's 100, that it's 20 from top to bottom, and it's 50 from front to back here. On this one we're told that it's 100 this way, this time it's only 15 across there, and we've got a size of 60 running up and down this side. So the question I'm going to ask you then is, of all these numbers, which of the numbers is the length of the wood? Which of the numbers is the breadth? And which is the thickness? For certain materials, say this was a lump of plasticine, or a piece of stone, or a piece of MDF, the length, the breadth and the thickness are, by and large, you can decide which number is length, breadth and thickness. But when it comes to a piece of wood, there's a little convention that we have to follow, that the length is always along the grain. Always along the grain. So in this little block, in block number 1 here, we can see that the grain is running this way. So in other words, that block has a length of 100. In this block right here, we can see that the grain is running top to bottom. So the size that's going along the grain, the length of it is 60. It's not always the biggest number. It's not always the number that's like on the flat. It could be going the other way, but it's always the number that points along the direction of the grain. The breadth also has a little convention attached to it as well. The breadth is the number going across the grain. So once you've established the direction of the grain, ask yourself which number cuts across it like a saw. And in this case, it's the 50. So this piece of wood has a breadth of 50. Up here, there's the grain going along it. Which number's cutting across it? It's this one right here. So this piece of wood has a breadth of 100. So then, which is thickness? Well, the one that's left. So the one that's neither length nor breadth must, in that case then, be thickness. So this is 15 thick up here, and this is 20 thick over there. So now we're going to talk about cutting lists, and before we get started in all that, it's worth talking about what a cutting list actually is. Well, it's a document that you're going to have to write, which resembles a shopping list. It's a shopping list for wood and materials, and in the cutting list you're going to outline all the parts, all the bits of material that you're going to need cut so that you can make the thing that you're going to make. Right? So in this case, a cutting list describes all the raw materials, the sizes of the raw materials that you need in order to make a thing. It's really as simple as that. There's just a couple of sort of funny things to a cutting list. It has to be laid out in a certain kind of fashion, and we'll talk about that in a little minute. You have to be quite specific with your sizes. And also things tend to get a little tricky if you've got a shape which ultimately is going to be like curved or something like that. Into your cutting list, you have to put the size of the plank or the piece of material from which you're going to cut your more intricate shape. So we're always dealing with rectangles, really rectangles and squares when it comes to cutting lists. Let's get into it. Let's talk about some basics to do with cutting lists, and I've got a part here, I've got a working drawing, pardon me, of a thing here, a wooden thing, and I've indicated on it the direction of the grain, and I've given some dimensions. I've also referred to the drawings properly. I've got an elevation, a front view, a plan, which is a top view, and an end elevation, which is a side view. So this is what this shape looks like from the front, the top and the side. You can see here I've also got a little piece of hidden detail, okay, and that little dashed line there represents the fact that there is a hidden edge over here that we can see, that we can't see. We have to still draw it. So the question will be asked, if you wanted to make that piece of wood, how would you fill out a cutting list? A cutting list, after all, is a list of square or rectangular pieces of wood from which you can make your components, and this is one component. So a cutting list is almost like your shopping list. How could I go ahead and make that component? What size of material would I need? Well, a cutting list you tend to follow these kind of columns right here. First of all, you give your part a name. Doesn't really matter what. What will we call this? We'll call this the side piece, okay? So this is the side piece. How many of them? Quantity do we want? Only want one of these. What material shall we make it out of? Well, I'd quite like it made out of pine. Thank you very much. And then we go to talk about the length, the breadth and the thickness and stuff. We've got a bunch of sizes here. We can see that this tall end is 100, the short end is 60. We can see that it's 30 across here, front to back, and it's also 100 wide. We know that length runs in the direction of the grain. Okay, so that means that either this or this, these are both lengths because they run in the direction of the grain. The arrows go in the same direction. But what do we put down inside our length box? Inside our length box, we have to write down the size of the plank of wood that we'll need to make this shape. And as you know, what we'd have to ask for is we'd have to get a piece of wood about that size. And from that then cut away this bit here. So into our length, we would write 100, like this. Then we need to ask ourselves, okay, well if that's us got the top to bottom size figured out, that's length, which is breadth and which is thickness. It looks to me that breadth is across the grain, like this. So breadth is across the grain, which means breadth is also 100. And thickness, what thickness of wood do we need? Is that size in right there. It's 30. And what that would effectively give us is that would give us a piece of wood that was kind of plank of wood. Well, let's just draw this in with solid lines. A plank of wood that would be as big as that. 100 in length. 100 in breadth and 30 thick. We would then have to remove this portion up here. So it's important you realise that when you come to do cutting lists, you're asking for a piece of wood, a plank of wood that is as big as possible. The largest possible part you need to get the whole thing out of, including the waste wood as well. Right, so let's see if we can figure out what this working drawing is all about and if we can write a cutting list for it. Let's put the cutting list to one side for 1 second because our main job initially is just to figure out what it is that we're looking at here. What have we got? Now, a working drawing isn't something that you can glance at and in one moment understand what's going on. It's like a piece of music. You have to just sort of puzzle your way over it and try and figure out what it's telling us. So, we've got an elevation. Let's write this in so we know what we're talking about here. We've got an elevation, and that's a kind of front view. We've got a plan view, and we've got an end elevation, side view, of this hardwood tray. Sizes are in millimetres, and we've also got a little pictorial sketch as well. Hopefully the camera is also picking it up. But we've also got an indication of what direction the grain's going in any of these parts. That's going to help us determine what length is. So let's see what we've got. This is probably the easiest drawing to understand. The first job is to figure out all the bits and pieces that we've got in front of us. And on the face of it, it looks like this box is made of five pieces. 2 handle pieces, a back and a front, and a base. But then you think to yourself, now wait a minute. Are the front and the back the same? And we can look at these drawings here and we can determine that the front and the back are indeed the same. Exact same length here, exact same height, exact same width in both cases. So the front and the back are the same, and it looks also like the 2 handles are the same. So in effect we've only got 3 different parts here. We've got the front stroke back, we've got the 2 sides, and we've got the base. So that's our first job inside the cutting list, is to write that down. So we've got the front and back. The front and the back, we've got the handles, and we've got the base. How many of these do we need? Well, we need 2 of those, the front and the back. We need the 2 handles, the left and the right, but we only need 1 base. And that adds up to our 5 components. 1, 2, 3, 4, 5. Right. The next simple bit then is material. Let's look over the drawing and see if we've got any clues about what material this tray should be made from. We've only got 2 clues. The title is that it's a hardwood tray. That's the first clue. And the second clue is that it tells us here that the base is made of plywood. So let's pop that in immediately. So the base is made of plywood, manufactured board. And the rest of it, it just says it's hardwood. So let's be specific. Let's say that the front and back are made of oak, and the handles are made of beech. You can write any suitable hardwood in there. That's what I'm going with. Right, now on to the sizes of things. So we need to now scan the drawing to see if we can find the length, the breadth and the thickness of these parts that we need. So let's look for the front and back first of all. So this part here, it's the long thin parts in the 3D drawing. It's the long thin parts, that's the front there, and that one's the back in there. So we have to figure out how long, how wide and how thick this is. So let's look over the drawing and see how long it is. Remember, length runs in the direction of the grain, and we can see here that the length of it is 200. Breadth runs across the grain. So breadth goes in this direction. I know as we're looking at this piece of paper right now, you might call that height or something like that, but you've got to keep in mind the fact that we're looking at the grain. Length goes along the grain and breadth goes across the grain. So let's see if we can get a size here. Well, we can. It tells us here that between there and there is 106. But wait a minute, because that size also incorporates a little bit of base as well. So it takes us 106 to go across that, and it also includes the base. So we're going to have to do a subtraction here. We're going to have to do 106, take away the thickness of the base. 6mm plywood is what the base is made of. So it's 106, take away 6, leaves us with 100. And the thickness, how thick is the front piece? Well, we can't see thickness in this side. We can see thickness here, that's the thickness of the part right there, but there's no dimension, we're only told an overall dimension here. Let's follow that up, aha, there it's there. So it's 18mm oak. That'll be expensive stuff. Thickness 18. Alright, let's look at the handles now. So the handles, the length runs in the direction of the grain, and the grain in this drawing is going up and down. Does this tell us how long the handles are? It does not. But it does tell us over here. So it tells us that it's 150 from the very bottom of the box to the very top of the handles. So again, we're going to have to do a subtraction because that takes into account the thickness of the base. So it's 150, take away 6, 144 for the length of the handles. The breadth runs across the grain. Now, we've got an overall size here, and we know that the outside parts are 18. So we could do a calculation here, but it's actually written for us up here. So there's the breadth. In the top view, it shows us the breadth of the handles is 100. And the thickness, let's see, tells us right there where the thickness is. That's the thickness of the handle right there, 18. And finally, plywood, the base. Plywood, being a manufactured board, doesn't have a grain to it. In fact, it's made of layers where the grains alternate in different layers. The grains go orthogonal angles, 90 degrees with every layer. So it doesn't really matter what we pick as the length of the breadth, it doesn't really matter. So why don't we just pick this one here? So there's the base. The base runs the whole way across the box. So let's say that it's 200 long, 200 millimeters long, and that its breadth would run from front to back that way. That's the breadth there. That's the length. It's 200 long, and the breadth is this size right here, 136. And where do we get the thickness from? The thickness comes from this note right here, so we know that it's 6 millimeters. And that's our cutting list completed.